Dear friends, I want to explain the strange calculation of the bevel gears. We know that strange calculation carried out according to the bending stress. This is called the beam strange calculation of the gears, and contact stress according to the Hertz stress equations. At first, we define the equivalent number of cities, which we use it for the finding or the selection of the tooth form factor from the tables. For the determination of the equivalent number of cities, we will use the thread-called approximation. What is the thread-called approximations? We know that for the involute gas, for the spur gas, tooth profile may be generated by the edge of the plane which rolls on the base cylinder. But for the bevel gears, this is maybe say as this forms. For the bevel gears, plane rolls without the sliding at the surface of the sphere. But it is not possible to represent on the plane surface the exact profile of bevel gears. Therefore, it is important to approximate the bevel gear tooth profile as accurately as possible. These call it as approximation. Approximation called as thread-called approximation is based upon the fact that cone tangent to the sphere at the pitch point will closely approximate the surface of sphere for a short distance. Is the site of the pitch point, which shown in this figure. This cone, call it as back cone, and this angle is the pitch angles. And number of the equivalent number of the T's must be defined at the equivalent spur gears, which pitch circle radius is equal to the this distance, this back cone radius, RB. In this figure, RB is back cone radius, and this is the bevel gears, and this one is equivalent spur gears. And number of these trees call it as the equivalent number of cities. Equivalent number of cities calculated as these forms, depending of the pitch radius of the cone, pitch radius of the cone, and pitch radius of the back cone. TA is number of the equivalent trees, and M is model. Okay. Equivalent number of cities also may be explained on this sketch. This is original bevel gears, and this ones is equivalent spur gears, which radius is equal to back cone radius. DVE1 is pitch circle diameters for the equivalent spool gears. And DE1 is external pitch circle diameters for the bevel gears. Delta 1, we know that this is pitch circles. From this sketch, it is very easy to find these equations. Equivalent number of the equivalent diameter of the bevel gears calculated as these forms, dE1 divided by cosine delta 1, and this is for the gears. This is for the pinion. If you taking into account the formula for the calculation of the pitch circles, dVe maybe expression as this was ZV and ZV1 ME and DE Z1 ME. From this calculation may be find the number of the equivalent ZV1 is equal to Z1 divided by cosine beta. And from depending of this number, equivalent number, we will find tooth form factors, the tooth form factor U by Fs, this tooth form factor, and we will calculate the bending strength in the meshing process. Sigma F is bending stress. We know that F from the word of foot, and UFS is tooth form factor. Ft tangential force acting on the trees. Kf, call it as a loading factor according to the bending stress. Kf calculated as these forms: Kf alpha, Kf beta, or sometimes maybe Kf there. Okay, but this theta f, this is factors taking into account the decreasing of the loading capacity of bevel gears according to the spool gears. Loading capacity of the bevel gears is consist of approximately 85% of the spool gears, because eta f may be taken as 0.85. B is phase width, B is phase width, and Mn is normal model. All parameters on this figure, I think, is clearly. Q maximum is distribution load. Force acting of the bevel gears may be calculated according to this sketch, sketch for the determination of the force acting on the bevel gears. We know that in the engagement acted the normal force, Fn, this normal force, Fn, or in this sketch is Wn. Fn divided, it is two components. One component is tangential force, Ft, tangential force, and other component is radial force. But this radial force, Fr prime, also is divided two components. Pure radial force, which acted to the perpendicular direction to the shaft axis, and Fa is axial force. This is directed as parallel to the shaft axis. We know that on the meshing process acted three forces. radial force, tangential force, and axial force. Radial force, normal force calculated as tangential force divided by cosines alpha. Alpha is pressure angle, which generally is taken as the 20 degrees for the involute gas. If T is tangential force, may be calculated depending of the transmitted torque T and mean diameter of the cone. dm, mean pitch diameters of second, according to this point, these points. Okay, this dm2 from the from the middle point of the trees, and radial force may be calculated from this sketch. From this sketch, according to the triangle rules, if R is equal to Ft tangent alpha cosine beta, and Fa equal to Ft tangent alpha sine beta. For the bevel gears, radial force acting to the pinion, if R1, is equal to axial force acting to the gears, if A1, and vice versa. Axial force acting to the pinion, if R1, is equal to radial force acting to the if R2. From this sketch, we point at this form. This FR, radial force for the pinion, but this is axial force for the gears, because FR is perpendicular to the shaft of the pinions, and FR also is parallel to the shafts of the gears. Okay. Contact strength of the bevel gears calculated according to the Hertz equations. This is Hertz equations. First equation is the Hertz equations. Q is distribution load. Eg is equivalent in model of elasticity, and rho G is equivalent radius of curvature of the tooth profile. For the calculation of the contact stress for the bevel gears, we must define the equivalent radius of the trees. Here, rho G, this rho equation for the equivalent radius of the keys. This may be found from the sketch of the contact stress from this sketch, and maybe fine from this sketch, maybe fine, and at least using the trigonometrical formulas between the cosines of the angle to the tangents of the angle, may be find that these equations, but you for the right angles the bevel gears, which U is velocity ratio is equal to tangents delta 2, because from tangents U square, and after the writing of this formula in the place of the Hertz equation, may be find the contact stress for the bevel gears according to these formulas, e.g. equivalent number of cities, and T1, this is torque on the pinion shafts, and KH is loading factor, which calculated this KH is equal to KH alpha, KH beta, and KHV. Alpha factors taking into account the distribution of the load load between the trees, and KH beta. This factor takes into account the distribution of the tooth along the trees. These factors call it also as concentration factors, and KHV is dynamic factors. And from these equations, contact stress equations, maybe find the pitch circle diameters of the gears according to external point of the trees. These formulas may be used, will use for the design of the Bevel gas transmission mechanisms. Okay, in these formulas we use the torque on the output shaft, and sigma H is contact stress, may be found as according to the material of the gears and for the methodology of the determination of the allowable stress, allowable contact stress. And KBE 0.25 B, this is this is his this phase factor, depending phase factor depending on actually. And also Bevel Gearing strength calculations may be explained on this slide. This is a bending stress, and this is general used as contact stress. These equations, ZH, ZM, this is factors depending on the materials and tooth forms, and WHT is distribution load. WHT is equal to QM. These equations also may be used for the design of the gears, for the finding of the pitch circle diameters of the pinion according to the mean middle point. After that, taking into account these equations on the Hertz equation, maybe find these equations for the calculation of the DM, and these factors KD factors depending on the type of the gears. For the straight toothed gears is 75. For the helical gears is 68. 78 is 68. Strength calculation of the Bevel gears also may be carried out according to the modified Lewis equations. This is Lewis equations. Sigma 0 is allowable static stress. U dashed U dashed Y is the tooth form factor or Lewis factor for the equivalent number of the teeth. These factors may be selected from the table, standard table, according to the equivalent number of the trees. And these factors, L minus B divided L, call it as a bevel factor, where L is slant height or corner distance. This is equal to the R, external corner distance RA, and P is phase width. Okay, corner distance may be calculated depending of the pitch circle diameters of the pinion and the gear for the gears. Okay, from the according to the triangle rules. This is all notes may be useful for the strange calculations, and this methodology takes from the textbooks by Khurmi. Okay, thank you very much for the attention. I wish you all success for you.